Hello everyone, good evening. My name is Hasanum Nashith. Today I'm going to talk about AWS security fundamentals. Let's get on to the topic. I'll be speaking about AWS, its features and benefits, cloud architecture, shared responsibility model, core pillars, and then strategies for safeguarding AWS. So let's start with the topic AWS introduction. What is AWS? AWS stands for Amazon Web Services. Amazon Web Services is a comprehensive and widely adopted cloud computing platform offered by Amazon. It provides a vast array of on-demand services including computing power, storage, databases, and more, accessible over the internet on a pay-as-you-go basis. Key advantage of AWS is its pay-as-you-go pricing model. Users only pay for the services they consume, making it a cost-effective solution. AWS enables individuals, companies, and governments to build and run applications, store data, and manage their IT resources with greater flexibility and scalability. AWS offers a vast range of services that can be broadly categorized into compute, storage, databases, networking, analytics, machine learning, and more. Now let's get into the topic AWS key features. Flexibility. AWS supports various operating systems, programming languages, and databases. Secure. AWS provides robust security features and compliance certifications, ensuring data protection and privacy. Scalable and elastic. Scalability refers to the capability to increase and drop the computing services depending on the business needs. Elasticity is defined as sharing the incoming operation business to multiple resources like Amazon EC2 cases, IP addresses, Lambda functions, and etc. Elasticity balances the traffic load and scalability balances the computing services. Cost effective. You only pay for the resources you consume. Experienced. The AWS cloud provides scale, security, trustability, and sequestration situations. AWS has erected a structure grounded on assignments learned from over 16 times of experience managing the multi-balloon bond. Let's get into benefits part. Payment model. AWS customers only pay for the resources they consume, eliminating the need for large upfront investments in hardware and infrastructure. Operations. AWS handles the management and maintenance of infrastructure, freeing up IT staff to focus on core business activities. Flexible capacity. Flexibility is achieved by allowing users to choose the operating system, programming language, database, and other services they need. Economy. Pay-as-you-go model coupled with economies of scale results in lower variable costs compared to traditional IT infrastructure. Global reach. AWS offers a global network of data centers, allowing companies to deploy their services worldwide with low latency. Increased speed. Provisioning services and IT infrastructure can be done in minutes, rather than weeks or months. This speed enables business to be more agile and quickly respond to changing market conditions. Moving on to the topic, AWS Cloud Architecture. So this is the AWS Cloud Architecture. On the left hand side we have Web Client. Web Client is any application or device that interacts with AWS services via the internet. Next we have Amazon Route 53. Route 53 is a cloud-based domain name system web service provided by AWS. It acts as a translator, converting human-readable domain names like www.example.com into numerical IP addresses that computer use to connect to each other. Elastic Load Balancer. It directs traffic to web servers, significantly improving performance. It can dynamically scale and adjust load balancing capacity based on traffic conditions. Next we have Amazon Relational Database. It offers access to database engines like MySQL and Microsoft SQL. It is compatible with various applications, queries, and tools, making it a versatile solution within Amazon RDS. Next is Amazon Simple Storage Service. It is a cloud object storage service provided by AWS that offers scalable, secure, and durable storage for various data types. Next is Amazon CloudFront. Amazon CloudFront primarily serves as a content delivery platform for websites. It delivers various types of content such as static, dynamic, and streaming content using a global network of locations. The next topic we have is AWS Shared Responsibility Model. AWS Shared Responsibility Model is a framework that divides security and compliance responsibilities between Amazon Web Services and the customer. AWS is responsible for the security of the cloud infrastructure, including hardware, software, networking, and facilities, while customers are responsible for securing their applications, data, and configurations within the AWS environment. Customers must manage aspects such as data encryption, identity and access management, and the security of their operating systems and applications. This model emphasizes collaboration to ensure a secure cloud environment, whereas AWS provides the foundational security and customers implement their own security measures. So first, let's discuss the responsibility of AWS. First is software. AWS provides various software services that enable developers to build, deploy, and manage applications in the cloud. This includes services like AWS Lambda. Next is compute. Compute services in AWS provide the processing power needed to run applications. Key services include Amazon EC2. Storage. AWS offers various storage solutions to meet different needs, including Amazon S3, simple storage service. Next, we have database. AWS provides managed database services that simplify database management. Key offerings include Amazon RDS, Relational Database Service. Networking services in AWS enable secure and efficient communication between resources, like Amazon VPC, Virtual Private Cloud. Hardware. AWS hardware infrastructure includes the physical servers, storage devices, and networking equipment that support its cloud services. AWS data centers are equipped with high-performance hardware to ensure reliability and scalability. Regions. AWS is organized into geographic regions which are isolated from one another to provide fault tolerance and stability. Each region consists of multiple availability zones. AWS currently has multiple regions around the world, allowing customers to deploy applications closer to their users for lower latency. Availability zone. An availability zone is a distinct location within a region that is engineered to be isolated from failures in other AZ. Each availability zone has its own power, cooling, and physical security, and is connected to another availability zone in the region via low latency links. This design allows customers to build highly available applications by distributing resources across multiple availability zones. Edge locations. Edge locations are data centers located in various geographic locations around the world that are used to deliver content to users with low latency. They are primarily used by services like Amazon CloudFront and AWS Global Accelerator. So let's get into customers' responsibility for securing AWS. Customer data. Customers are responsible for managing and securing their data stored in AWS. This includes data classification, data encryption, and data backup and recovery. Platform applications and identity and access managements. Customers are responsible for securing their applications, including applying security patches, managing application vulnerabilities, and ensuring secure coding practices. Customers must configure IAM policies to control access to AWS resources. This includes creating IAM users and groups and assigning permissions based on the principle of least privilege. Operating system, network, and firewall configurations. Customers are responsible for the security and configuration of their operating systems and network settings. Operating system security. Customers must manage the security of their guest operating systems, including regularly applying security patches and updates, configuring and monitoring for unauthorized access or vulnerabilities. Network configuration. Customers are responsible for configuring their virtual networks, including setting up Amazon VPC to define network boundaries, configuring subnets, route tables, and internet gateways, implementing security groups and network access control lists to control inbound and outbound traffic. Firewall configuration. Customers must configure firewalls to protect their applications and data. This includes setting up security groups in AWS to control access to EC2 instances, configuring network ACLs to provide an additional layer of security at the subnet level. Encryption. Client-side encryption. This involves encrypting data before it is sent to AWS. Customers can use libraries or tools to encrypt data on the client side, ensuring that sensitive information is protected during transmission. Server-side encryption. AWS provides options for server-side encryption for data stored in services like Amazon S3 or RDS. Customers can choose to enable server-side encryption using AWS managed keys, customer managed keys, or customer provided keys. Customers must ensure that they configure these settings appropriately. Network traffic protection. Customers should use secure protocols like example HTTPS or TLS to encrypt data in transit between their applications and AWS services. This protects data from eavesdropping and man-in-the-middle attacks. So this is same as the above mentioned responsibilities. On the left hand side you can see that these are the responsibilities for AWS, and the right hand side these are the responsibility the customer should take. So let's discuss the topic core pillars of AWS. Operational excellence. Operational excellence is a commitment to build software correctly while consistently delivering a great customer experience. The operational excellence pillar provides an overview of design principles and best practices. Security. Security pillar encompasses the ability to protect data, systems, and assets to take advantage of cloud technologies to improve your security. The reliability. Reliability encompasses the ability of a workload to perform its intended function correctly and consistently when it's expected to. This includes the ability to operate and test the workload through its total life cycle. Performance efficiency. This includes the ability to use cloud resources efficiently to meet performance requirements and to maintain that efficiency as demand changes and technologies evolve. Cost optimization. This includes the ability to run systems to deliver business value at the lowest price point. Sustainability. This pillar focuses on environmental impacts, especially energy consumption and efficiency, since they are important levers for architects to inform direct action to reduce resource usage. So then let's discuss the last topic, strategies for safeguarding AWS. First is planning. We have to define business objective, compliance requirement, and threat models before migrating to AWS. Use the AWS well-architected tool to assess workloads and embed security controls from the outset. Embrace the cloud. Leverage AWS native security capabilities like IAM, VPC, security groups, KMS, Shield, WAF, Inspector, and GuardDuty. Use them early and often to establish a robust security foundation. Define a security baseline. Let's discuss this both. Define a security baseline and embrace the baseline. Translate your security standards into code using infrastructure as a code (IAC) tools like CloudFormation and or Terraform. This ensures consistent and repeatable deployments. Embed baseline checks within your CI or CD pipelines to prevent insecure configurations from ever reaching production. Next, let's discuss access limitations. Apply the principle of least privilege using IAM roles rather than long-lived credentials. Enforce MFA, multi-factor authentication, and rotate keys regularly. Structure your environment using AWS organizations to separate accounts by function or sensitivity. Identify vulnerabilities. Use AWS Inspector to scan EC2 instances, containers, and Lambda functions for vulnerabilities. Collect and protect logs. Enable comprehensive logging. CloudTrail, CloudWatch logs, VPC flow logs, DNS logs, and ELB or S3 access logs. Store logs centrally in an encrypted write-once S3 bucket with integrity validation and MFA delete enabled. Monitor, detect, and react. Implement continuous monitoring with GuardDuty, Macie, CloudWatch alarms, and Security Hub. Integrate these with SIEM, SIM tools for real-time threat detection. Unify AWS with on-premises and other cloud security. Create a centralized security posture by integrating AWS environments with on-premises and alternative cloud platforms using SIEM, CSPM, and Security Hub. Standardize policies, tagging, and governance across all environments. This hybrid approach ensures visibility, compliance, and unified controls across your entire infrastructure. Automate. Automate baseline performance with AWS configuration and CloudFormation. Patch management with System Manager and vulnerability scanning with Inspector. Now, let's conclude our session. In conclusion, Amazon Web Services offers a powerful and flexible cloud computing platform that enables business to scale efficiently while maintaining a strong focus on security and compliance. With its global infrastructure, AWS provides the ability to deploy applications across multiple regions, ensuring high availability and performance. By leveraging AWS capabilities, organizations can enhance their operational efficiency, reduce costs, and innovate faster in a secure environment. Understanding these key aspects of AWS is essential for effectively utilizing cloud technology to meet business needs. Thank you everyone.